So basically what's going on is as follows. We have a big old turbine with big old blades. Artist rendition. All right, flow is coming in from the penstock. So at the very end here, we have an exit diameter for the penstock. Right, that's what you need to use to determine the velocity coming into the turbine. What's hitting the turbine is coming from the end of the penstock. Right, that's one thing. Once it's hitting this, what it's doing is it's imparting a torque. So that torque is coming from equation 6. The actual power is coming from the velocity entering and leaving the turbine blades. So the first thing you would do is compute the turbine power itself using equation 5, compute the torque from the supplied fluid using equation 6. So it's going to hit this and it's going to generate some type of torque here. W dot over omega. Now, for this to be moving at a constant angular velocity, this has to be balanced by another torque. That's basic dynamics. So that other torque is coming from friction in the shaft. So that torque would be computed from this other model that I gave you in equation 4. This resistance coefficient K times the inner radius r squared times omega. So the idea in part 4 is you are going to compute, for a given Q, you're going to actually, and a given omega, you have to assume one. You're going to compute W dot. You're going to compute your torque. And then from that, you are going to calculate a new omega. From this. That's the general idea. And when the omega that you are specifying matches what comes out of this, your torques are balanced. Now again, in part 4, I gave you a reference set of values to use just to check yourself. For the angular velocity that I specified, 29.6 RPM, at the volumetric flow rate that I gave you in part 3, 17.2 cubic meters per second, right, they ought to balance. So all of these calculations for W dot, for this torque, for this new omega, you have to put these calculations somewhere in your spreadsheet because you're going to use them. So hopefully these two parts, isolated from each other, will give you an idea of how everything's supposed to work. Finally, the last piece is let's put it all together.
Do you mean the spreadsheet from part 3?
I'm sorry?
Do you mean these will be used in the spreadsheet? Is that what you're talking about?
Yeah, when you say that you
Include a sheet from part 3?
Yeah, you said you'll need this for your spreadsheet.